how do you see yourself, right? What do you want really to learn and to be, let's say, an expert?
Welcome to the LabVIEW Experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes. I'm here today with Juan Navarro of LabVIEW Studios. You're in what part of Mexico are you in?
Monterrey,
Okay.
Mexico.
So remind me of my Mexican geography because I'm not super familiar with it. Where is Monterrey?
Yeah, it's northeast of Mexico.
Northeast. Okay, are you on the Gulf Coast then?
Yeah, exactly. Well, not in the Gulf, but a little bit in. But
closer,
it's still
like
northeast.
below Texas, kind of somewhere.
Yeah, exactly. They are kind of our neighbor. Yeah.
Okay, cool. So you and I have known each other for several years now, right?
Yes, several years now.
I don't even remember how we meet. I think at one point we met because I had a Git course and you were trying to teach Git in Spanish or something. Does that sound about right?
Yes.
I remember us talking about that.
Yes. Actually, I saw some things you were doing. I saw your course. We actually had just one of those, and we said, okay, maybe we can do something way better, but in Spanish, and then do some joint venture together. But in the end, didn't fly because there is not much demand for that. I was expecting more.
I've thought about trying to do training in Spanish because I am fluent in Spanish, but I find that those things would be better for the most part to send them to people like you and Enrique, partially because like your Spanish is better than mine, but not, that's not really my problem. But the big thing I think is selling to people in other countries. Do you have the exchange rate problem? And like what I would want to charge is way more than they can afford. And so like sending them to somebody local, then that eliminates at least that part of the equation.
Yeah. The scale of the economy changes, and from the business side, that's always an issue. That's always an issue. Yeah.
Now, when we had talked, you guys were looking to do some training. So for your business, for LabVIEW Studios, do you do a lot of training, or is it like, tell me a little bit more about your business and what you do?
Yeah. Well, the main businesses here, it's the integration part, create stuff, software, which is consulting and all these things, and and actually courses, right? Like lectures for LabVIEW and all that stuff. Not only LabVIEW, but mainly stuff related to the NI environment, right?
All right, so that leads me to a couple of questions. First question, so you do software, do you also do hardware stuff, or do you let that to somebody else and you just do the software side?
No. We also do hardware. Yeah.
I was gonna say I see a C-Rio sitting on your desk behind you or something, or a CDAC or something.
Yeah. Actually, that's a cool experiment we're trying to do with EtherCAT and another company who is trying. Well, they only use EtherCAT for some reason for their DACs. So we are trying to see how can we connect them. The Rio has this capability, and we are trying to make it work. Still with some issues, as you can see.
Yeah.
So, but we do hardware. Yeah.
Cool. Another question I had, you mentioned courses. I'm curious, who are your target audience for the courses? Are they other system integrators? Are they engineers who just happen to use LabVIEW occasionally? Like, and what exactly are you teaching them? Is it basics or advanced or?
Okay, actually, well, I would like to say that mostly is advanced users, but no, actually, in general, it's companies, and those companies are required like LabVIEW 1 and 2 because normally those testers are sent from other parts of the world, right? Like US, Germany, and stuff, and those things come here, and they have to debug them and do all more basic stuff normally. Maybe going up to LabVIEW like the equivalent to Core 3 or something, but normally that's the main bulk of courses. Also test stand, but in the same more or less level. Yeah.
So you talk about debugging. I have an interesting question. So when I worked at Westinghouse, I always liked when I built test systems to always built an executable and put the executable on it because I didn't want people messing with it. But
Yeah.
I've been talking to a lot of people lately that tend to run like full development environment on their test stations, and I'm
Yeah.
curious what you see in that area because when you mentioned like debugging and stuff, I'm assuming then they have the IDE on the test station.
Yeah, yes. Actually, I think that's a very interesting question, and it's a very different thing, or how it works in the US and here. And I would have been talking about that like in other meetings, like in mastermind thing. But here, many of the times there is the IDE. It is or either for test stand, for Lab Windows CDI, for C Sharp, or for LabVIEW, or for whatever. Normally they are there because if something happens, they want to patch it very fast, and even and that's why they need those trainings. So mostly here it's sometimes they use executable, but not that much. I would say that 60% of the time they have the IDE inside, and they recompile and they patch stuff very very fast so they can keep producing.
Okay. Yeah, I guess it depends on exactly what you're doing too. If you're manufacturing end of line test, right,
Yeah,
having the line
exactly.
down for a while is hard. I was doing a lot of stuff when I worked for Westinghouse. We were testing nuclear power plants. So obviously, like you don't want people messing with it, but also like when the plant went down, there was always like a critical path to getting it back on. And as long as you weren't on the critical path, then time was not as essential, right? So
Yeah,
we always just tried not to be on the critical path. So there's always
yeah,
something else holding them up, and then we can take our time and do things. When you're the critical path, though, then they want it up and running right away. So there's definitely a little bit of
exactly.
that. Yeah.
Exactly, and in that case, like days or hours count, right? Because you are not producing, you are losing money. For manufacturing companies, it's like that, right?
Yeah, yeah. Well, nuclear power was the same way. The quote
Ah,
used to
okay.
be they generated like $1 million a day in electricity or something.
Oh,
So yeah.
oh,
So if you're down for a day, that's like, and that was like an old number, so it's probably way more than that. So
oh,
yeah, downtime was very important. And also, like the other thing with nuclear power plants is like anytime you shut down, it takes like a day or two to get started back up because if you have an unexpected shutdown, you had to call the NRC and explain to them why you shut down and get them to okay starting back up. So it's always like a 2 or 3 day process. So you never like
okay,
you wanted to shut down the plant if you needed to because like really bad things happen if you don't, but like
yeah,
also you want to avoid it as much as you can too. So it's like a
yeah,
double-edged
makes
sword.
sense.
Yeah.
Oh, I didn't know it was nuclear power plants. That's another business, I think, compared to power plants in general.
Yeah, yeah, yeah. I mean, I think regular power plants have some safety issues, right? Like if you get a big coal boiler or something like, yeah,
Yeah,
okay, yeah, that could blow up and whatever, but it's not quite the same as with blowing up a nuclear power plant. I think that would be a little bit more
yeah, yes.
devastating. Yeah. So, very interesting. You mentioned the mastermind group. How you've been in there for a couple of years now. Do you want to talk a little bit about that? I'm curious,
Yeah,
I'm curious to hear your opinion about how it's going and what you get out of it. And
yeah. Actually, for me, it's a way to be like always sharp on new things happening. Not only LabVIEW, because we are always talking about many things. Like I think LabVIEW is like 50% of the time, but the other times is like, hey, how did I check this thing in the web URL and then convert it to something else? And how do I put this LabVIEW part into Python thing and then this embedded system? Very very weird questions, and more related, let's say, to sometimes to philosophical software, like how should I do this, yeah,
yeah,
and yeah, how should I do stuff, like what is the best approach to do this, and that's very interesting. If I'm not in that area, for example, like you guys do plenty of executables and maybe I don't do that much executables, but in the end it's very interesting how you solve those problems, because eventually I will have them, or you learn something totally new, totally different. So for me, that's the main part of going there, just to go and hear new stuff that someone else is doing in some other part of the world. So it's cool.
yeah, I think that's interesting. I think it's good sometimes to take a step back. I think as engineers, sometimes we get so focused on the
Yeah,
technology and on solving the problem at hand that we lose sight of the bigger picture. And I
yeah,
think too, it helps to emphasize like the basic principles, like the first principles of building blocks of like, okay, we do TDD or we do CI/CD, but why? Oh, because we want
yeah,
quick feedback. Right. And then,
yes,
okay, so now you go into a place and they're not doing TDD or CI/CD and you're having trouble selling it. Well, okay, well, how can we get feedback? If we're not going to do that, let's find a different way to get feedback. So you're still going back to like the first principles, which I think is really interesting. And I read an interesting article by Martin Fowler. It's been making around something
Mhm.
about like the expert beginner, which I thought was
Okay.
really good. Yeah.
Oh,
Because it was talking about how like, you know, the people that thrive currently in the software engineering world, like they used to talk about like T-shaped knowledge where you know one thing really good, but it's like it's somewhere in between a generalist and a specialist, right? So a generalist like
yeah,
knows a little bit about everything, but they're not really
yeah,
good at any one thing, right?
yeah,
And a T-shaped thing is like I know all about this one thing and maybe a little bit about the periphery, but like there's this idea of like an expert generalist who like knows several things really well and is really good at like learning new things.
yeah,
And I think a big part of that is understanding the principles behind it.
yeah,
Because once you understand the principles, then you can transfer that to any, like for example, like in LabVIEW, like if you may not be a C sharp or a Python programmer or something, but if you understand object-oriented programming, you understand the concepts in LabVIEW, then doing it in C sharp or Python, it's learning the syntax more
yeah,
than anything.
exactly.
Yeah.
Yeah, the basics I think it's the most important thing. How it's I call it learn to learn, right?
Yeah.
So you need to learn how to learn stuff. So once you learn it properly and you understand what is behind it, not only for example LabVIEW, but what is behind that, let's say well, I don't know, a technology or for example objects, and then you understand it, you can translate to whatever you want and make it as clean as you do it in LabVIEW, for example, because it's the same concept, the same basics.
Yeah, I'm reading this book right now, Learn Enough. There's a whole series. It's Learn Enough Python, Learn Enough JavaScript, or whatever, but
Oh,
it's like Learn Enough to be dangerous. But one of the things they talk about is the idea of like
it's a
technical
cool title.
sophistication. Yeah, it's a really cool title. But they talk about this term, they call it technical sophistication. I might call it like technical intuition or something. But it's like it's about learning how to learn, but it's also about like being able to discern what's important and not like going down
Yeah,
every rabbit hole, but understanding like knowing where to apply yourself
yeah,
and knowing when it's okay to like, okay, yeah, this thing just works and it's okay. I don't necessarily need to dive into it right now.
yeah,
But then, oh, when I do, I know how to find, like knowing where to find stuff, knowing how to use documentation, knowing how to read between the lines. Like, as an example, I talked to somebody and they were talking about how they had trouble with certain technical textbooks because the tutorial was written and then the
hmm,
version changed and like, oh, something moved around, a button moved around on the GUI or something, and they were having trouble following it. And I think that's like that technical sophistication is like, okay, there's a setting to set this thing. Great.
yeah,
And somebody would look at that in the book and say, oh, well, I have to go to settings and then to this, to this, to this to drill down to it. And somebody with technical intuition, if it wasn't there, they'd be like, well, where else might it be? And then they would navigate and find it.
yes, yes, and
Yeah.
also I think to be able to discern what to focus on or what not to focus, it depends on what do you want. How do you see yourself, right? What do you want really to learn and to be, let's say, an expert? So
Hmm.
following that path, you can train yourself to check what is important, what is not, to get to that point faster, right?
Yeah,
So
it's also,
that's the
yeah.
interesting thing.
Another part of it too is figuring out like what's immediately useful. So, I talk to people who
Yeah,
are in big companies and they're overwhelmed, and it's always like, well, find something small that you can do right now that then buys
yeah,
you a little more time. So, okay, you spend
yeah,
like an hour a day on this thing. If you could reduce that to 5 minutes, that gives you 55 minutes a day to then go do other things and build on that. And so it's like part of it is not getting overwhelmed and figuring out just a place to start. And I
yeah,
think sometimes people are like they try to find the perfect place to start, and it's like there is no perfect place. Like just pick something that's
yeah,
easy or something that you
yeah,
can see a path forward and go and see what happens.
yeah. I think like in life, right? There is um, no right place to be or to start or whatever, right? So you have to start, and of course you can find, if you learn to learn, right? You can find this small step to go up and up, right? But still, if you want to start with something, you just start, and then you will start figuring out and learning how to uh, figure out faster, right?
Inertia is very real. Yeah. Like if you're standing still, it's really hard to get moving. But once you get moving, it's easier to keep moving.
Yeah,
So yeah.
yeah, like physics, right?
Yeah, exactly. Um, so we mentioned other programming. Like you also do some C sharp and Python.
Yes, yes, that's something like customers have been, pulling into that. So some customers, for example, they require at the beginning like CVI or stuff because they do it in test stand and they hated LabVIEW, and then they migrated to C Sharp, and the other customers want C Sharp because they also hated LabVIEW for some reason. I'm not really sure about that. But they use Testan. So yeah, normally that's how we use it, like included in Testan. But we also do some other stuff like libraries and things like to integrate mainly with NI products, but not only, right? The same history with Python. Python with Testan, that's what people always want us to do, because there is some tricks, to connect it properly to Testan and get the errors properly and everything working properly in every language, how to take them out, that
I
information.
was gonna say in Python, how does the errors work? Because Python throws exceptions. So how does it catch? Does Tescan
Yeah,
catch those?
you have to make it catch it, right?
Oh,
So
okay.
you have this exception, and you have to parse it and then throw it into test stand. Yeah.
Actually, yeah, that's something like I've played around with the LabVIEW Python node, but I don't think I've played around with the exception handling very much. So yeah, I need to figure that out. I guess if
Yeah.
it threw an
Also C
exception, would it
sharp.
come
Also
out?
C sharp is the same.
Yeah. So I guess that's an experiment I need to do. But like run Python code that generates an exception and see what happens in LabVIEW. I would imagine if you do a function calling a generate an exception, I would think LabVIEW would catch it. It would come out in the error cluster. That's what I would
Yeah.
expect.
We can check
Oh,
it in the mastermind. I think would be a nice topic.
yeah. Actually, we should talk about that. Yeah.
Yeah, we can
Um.
do that for sure. Yeah, but
So
it's very
yeah.
interesting. It's very nice. Yeah.
So the question, one question I have is, so you do LabVIEW and TestStamp. When your customers ask you to integrate with C Sharp and Python, are you writing the C Sharp and Python code, or are you just simply calling it in TestStamp for the most part?
No. We write it. Yeah, because the issue normally is how do I connect this with this and do this test, but I want a DLL in C sharp. That's normally
Okay.
the
Okay.
request. So we write all the parts inside to be able to do that, and that's why we parse the errors to go into test stand normally.
So forgive my ignorance, but when you integrate C Sharp with TestStamp, are you calling like like text like C Sharp code, or are you building it into DLL and calling the DLL?
No, DLLs. Yeah,
Okay, so
yeah.
you have to
Normally
build a
we do
DLL.
DLLs. Yeah,
Because
yeah.
Python, right, there's no building step. You just, here's your Python script, you point at it and it
Yep.
goes. Okay.
Yes,
Just making
exactly.
sure I understand that correctly.
Yeah.
So last night I was at our local user group meeting and Tony Vento was there and he was making a big deal about LabVIEW and Python and how Python is kind of like, people are using it. It's kind of the future and it's not really this like either or and using both. I'm curious just your general thoughts on that.
Yeah. I think we have discussed that before. Yeah, I think Python, I don't like it much. I think it's a disordered language, right? I don't like it much, but for sure, if it's useful, then I use it, right? It's just a tool, right? In the belt, it's just not a hammer. I don't like the shape of the hammer, but
Yeah.
still, it's useful. Yeah,
That's
but
always a good litmus test. Yeah, if it's not useful and you don't like it, then why the heck are you doing it?
yes,
It's got to
exactly,
be at least one of
exactly.
those two things. Yeah.
Exactly, and for sure some libraries are really easier to use on that, on Python. So yeah, there, right there is the tool, but you have to choose the right tool for the right project, right? So Python sometimes is used for things that Python is not really that good at, so you use another tool and you can integrate them both. I think that's the best way to use them.
So another thing that comes up with text-based languages is using AI to generate code and or variety of other things. Is that something that you've seen people doing with Python in the test and measurement world, or is that something you've experimented with?
I have read about it, never done it myself. I have never seen that in the manufacturing world. Maybe in the US there's some experimentation on that, but I don't trust it much. It's the thing is that currently there is some depth, right? How would you say it's knowledge depth, right? Currently, there
Hmm.
is that, right? Everywhere in the manufacturing world. But if you include AI that kind of do the testing and then you cannot debug it, and then the guys who are supporting that cannot also debug it, then I think there is a big issue there. Um, Yeah, it's still starting. Let's see how it goes, but I don't think it's going to be as it will not change it as much as we think. Maybe for small things or for some ideas to prototype, I think it's great, right? But for building like stable products, maybe it's not the best approach.
I
Yeah,
don't know. In my experience, and my experience is pretty limited, it seems like it can generate code rather quickly, and it can be quicker than typing it out. But
yeah,
generally, like you gotta like triple check everything. And so I feel like whatever efficiency I feel like I'm gaining by getting it to generate quickly, I'm losing a lot of that by having to double check everything and having to debug it. And
yeah.
so yeah.
Also, you lose the ability to train junior engineers, right? So if they use those tools, they are not really gaining the
Yeah.
knowledge to become seniors, right?
Well, that is the other thing too. Like, I feel like if you were a junior engineer or somebody who didn't really know a lot, I don't think you would get a lot out of an AI because I think you would spend even more time debugging it and stuff, or you would just trust it and ship it, and then still end up debugging stuff. You just debug it after you ship it, and your customers are all pissed at you. And
Yeah,
so,
not a good
yeah,
idea, I think.
yeah, it doesn't sound great. But one comment that I heard you make earlier that I thought was really interesting, and you didn't use these words, but I think it was kind of like selling shovels because you hear that in like the AI debate of like you've got these big
Yeah.
companies that are pushing this AI thing, but the people who are really making money are the ones selling the shovels. It's Nvidia selling all the GPUs to everybody who thinks they're going to get
Yes.
rich do with AI stuff. And you made a comment something like, yeah, you don't have to be the main business, but if you can be a supplier and part of the supply chain, then
Yes.
then that can be a lucrative place to be.
Yeah, I think that's what's happening with Nvidia and with many other companies who are taking advantage of that. AI is the new boom, right? Like the new
Yeah.
gold rush, right? But the ones who are being really, gaining money, it's Nvidia and the ones who are doing the GPU and the infrastructure. Not only them, for example, the guys who are doing all the power supplies for those things, like Schneider and all those guys, they are doing a lot of money of AI, but they don't do AI. They just do the power supplies and the switchings and all the protections for that. But they are just in the supply chain. And I don't know. Currently, Nvidia it's like the most valuable somehow. I think last week it was something like that. So that's really, it tells you about how actually it works and how who is the really important guy in this supply chain, right? Yeah.
Yeah, I
So
imagine people building data centers are probably doing quite well, and probably a lot of
yes,
electricity generators are doing quite well. They're like, yeah,
exactly.
sure, keep generating all your memes, but we're just racking up money.
Yeah, exactly. Some of our customers actually they are doing some parts of these things, and they're like that's the main business of the planet right now. Like yeah, everything, yeah, switch, whatever, yeah, that's cool. But whatever is going to the power centers for the AIs, that's priority. That's makes more money. It's more specialized. They sell it like
Yeah.
more expensive. So yeah.
Yeah. Well, I feel like the whole LabVIEW test and measurement business is kind of built on that principle in the sense that, like, for the most part, like the test and measurement is never like the main show. It's always like the add-on.
Yeah,
Yeah.
yeah, it's always the add-on. Yeah,
Yeah.
yeah,
The,
makes
the
sense.
the trick in that department, I think, with test and measurement is not being seen as a cost center. That's the really, I mean, I think if you're doing R&D, that's less of an issue, but if you're just doing production line test, at that point it's like it's a cost and they want to try to drive it down as much as possible. Usually,
Yes,
yeah.
that's true. That's you see, I think that happens a lot. Like in this side, not sure if in the US is the same, but yeah, it's very people is very sensitive to price because they see it mainly as a cost because they are already producing and they say, okay, we only have this mistake or whatever is going on here, just patch it. But to inject money to improve it or to make it a little bit better so they don't have all those mistakes later, it's not, it doesn't happen a lot. And what happens in the end, I'm not sure if you hear the case of Takata, right? I think like 6 7 years ago they had this issue with the bags in the cars.
Airbags, yeah,
Yeah,
yeah.
so basically they died because there was this issue. It was tracked to one of the plants in Takata, and then they had to sell and everything, and they went bankrupt. And that
Oh,
happens in
okay.
the end. That happens in the end. In the end, they decided they want to pay like later when something happens or before. And well, it's I guess in the end is business for them. But I think it's not properly calculated sometimes that the
Yeah.
importance of checking that before, right?
Well, I feel
You
like
know?
there's larger economic forces at play too, though, in the sense that
Yeah,
like most companies, US companies who would outsource stuff to Mexico, they're
yeah,
probably outsourcing it more than anything to try to save money to begin with. Right. So
yeah,
they're already in that mindset of we're trying to cut costs by going to Mexico. So
yeah.
then being like, well, we need a better test system, blah, blah, blah. It's like, yeah.
Yeah, but that's interesting part. They're already cutting costs because well, here's cheaper, right?
Yeah.
They're already cutting costs and they want to keep
Cut
cutting costs.
even more.
It's like,
Yeah, yeah,
dude,
exactly. Because you're like, hey, you're already saving money by being in Mexico. Now you could have a better
exactly.
test system. Yeah.
Yeah, that's the thing that is counterintuitive because in the end it will take a chunk of money if they get a demand,
Yeah.
right?
Well, I do feel like there is so I'm not generally very super pro business, but I or big business, but I do feel like there is like you're balancing like the demand, right? There is like a cost benefit trade-off, and like at some point good enough is good enough. Like, depending
Yeah,
on what you're making, like obviously like the airbags thing, yeah, if you're killing people, yeah, you need a better
yeah,
test.
it's
But like
important,
if you're
right?
making widgets that aren't ever going to kill anybody, like you're making pens, like what level of quality do you really need it, right? I mean,
Yeah,
at that point, it's more of like just a marketing position, right? Do you want to sell your pen as like the premium premier pen that's like super well
yeah,
engineered, or are you just selling cheap Bics? In which case, like make them as cheap as possible,
yeah, yeah, for
right? As
sure.
long as they're right,
Depends on the problem. Yeah,
that's the test, and like yeah, so yeah, it just kind of
yeah,
depends on what you're doing. But it's interesting because as a consultant, I work on a variety of projects, and sometimes the projects are literally like testing pens, or I had a friend who was testing carpet fibers or something
yeah.
for strength.
Oh,
And like some of those jobs, like not to poo-poo anybody who does that, right? Like everybody plays a part and whatever, but it's hard to get excited about those things, because you're like,
yeah,
really, like, okay, you sell a few more widgets, or your carpet's just a little bit stronger, it lasts an extra day or something like,
yeah,
it's hard for me to get excited about that, but I did just start a new project for a company. They're doing some space stuff, and that's kind of cool. And
yeah,
it's not
yeah.
just any space stuff. They're
Rockets
actually like
always
part
is
of like
cool.
the yeah, they're doing part of the project to send people to the moon. So like that's pretty cool. And also it
Yeah,
has like real consequences too. Versus like,
yeah,
stronger carpet fibers, yeah, maybe there's like some small consequence, like, okay, yeah, if we don't do this eventually, so, we're going to decline and we'll have to lay some people off. So there probably are consequences, but it's not the
yeah.
same.
Yeah, but you see, I think who makes this kind of this business like boring is upper management because the thing is I think the problem with this with for example let's say the cheap pens, right, like big cheap pens, like these ones, like they want to produce it cheaper. What they do to make it cheaper? Maybe go to China, right? So they go to China, you manufacture this, I get this, I earn much more money. But what they are doing is outsource your business, right?
Mhm.
So it's like what happened to Compaq and all those things, right? So they outsource the business, and then the Chinese have everything to produce it, and they already do it cheaper. They create big two or Chinese big or something like that,
Yeah.
and they start killing big, right? So the managers, I think they do it in the engineering point of view like boring because they can invest on, okay, we need to keep this here, right? We need to control it,
Mhm.
but for that we need to apply more technology and interesting technology, even if it's something like a cheap dig, right? But maybe they can invest in manufacturing technologies and stuff like that to keep it here, to keep it cheap, and then keep competing, right? Because otherwise they will get eaten. And right now I think that's a topic. Many of the businesses are being eaten away by Chinese business, right?
Yeah.
And that's the reason they gave everything away, right?
Yeah. I think that is part of the problem. Like, yeah, when you outsource something to China,
Yeah,
potentially
yeah,
you're giving them all the technology. They're building up workers, and that even if they don't like directly steal it, which is like something that U.S. is
yeah,
always upset about Chinese people's not trying to be xenophobic here, right? Like I
yeah,
don't dislike China, but there is this rhetoric in the U.S. of like, oh, you manufacture something over there that Chinese
yeah,
steal. But even if they don't steal it, right? You've got people who work at that plant. Some other company hires those people. Those
yeah,
people, right? Even if they don't take the designs or whatever, they've got the knowledge of how to do this now, and they
yes.
go start their own competing company. So
Exactly.
it's not
Yeah.
surprising that
And the Chinese
happens.
is an example. It happens here. It happens here. I mean, people is not dumb. It's they just see the parts and they say, okay, I can do that. I can do that part. I can do that part. I can put it together and it's sell for what? Then I can sell it.
Yeah,
Yes.
exactly. Yeah, I don't think it's like, yeah, it's just the way the system is. I don't think it's
Yeah,
any kind of
exactly.
like moral failing on anybody's part. Uh, but there is also too in the US, and this may or may not be true in Mexico. I imagine it's true everywhere there's capitalism, but there's this like there's systemic forces of like when you're a publicly traded company, particularly in the US, it's very toxic of like it's all about shareholder value and
Yeah.
and it encourages a very short-sighted. So there's a couple
Yes.
problems. One is the short-sightedness of like we're just concerned about the quarterly things because I want to get my bonus or whatever, or we're afraid of the shareholders doing a hostile takeover or something. But then
Yes.
also there's this constant like search for year-over-year growth. Like we have to
Yeah.
keep growing. And I think if you there's a guy Ed Zitron who has a podcast. I forget what it's called, but you can look him up. But he's always talking about he calls it the rot economy. But basically, he's like the root of all of this is that companies feel the need to grow year over year, like show this tremendous growth. It's not enough to have like 10% growth. They want like 20,
Yeah.
30, like it's got to be double digits.
Yeah.
And his premise is that's a lot of what's driving the AI hype. Because
Yeah.
like if you look at what AI does, like I'm not saying it's not useful and that it doesn't have use cases, but the hype is selling it as like this, like it's gonna take over the world and it's gonna replace everyone. And you look at it, it's like it's
Yeah.
not there, but they're
Yeah.
selling it like it is, right?
Yes.
And the investors are investing like it is. And it's yeah, I think it's a big bubble that's gonna pop at some point, and we'll see what's
Yeah.
left after the bubble pops.
Yeah, exactly, and it's because they are looking forward for short term
Really
money,
high
right?
growth, yeah.
Yeah, short term. But if but that actually that's dumb because if they want to keep the company going more and more viable, like maximize that, they have to go in the short term. Sometimes they have to invest, and in long term, they will get more. I, for example, pay more to employees. For example, gravity payments. That's a great example, right? Like they pay fair wages to all employees, and they created growth, not only the company, and also they created retention, and they created like growth and welfare in the cities they were being there, right? Like purchasing houses and all kind of things, cars and whatever, because they were paid like a proper wage. But it's a way of investing in the future of the company, and you will get your money. It's just not that fast, right? But will be better the way you get it.
Yeah, I mean, I think to me, like that is the number one thing in business is like, especially as a small business, I feel like because small business, like it's hard to really scale like that. Like, sure, maybe one or two do, but like most of us are in it for the long haul. So having that long-term
Yeah,
vision is a
yeah,
much better, yeah.
yes,
Because also, well, that's the other thing though, too. Like Silicon Valley breeds this group of people who like join Y Combinator, and their whole goal is not to build a long-term sustainable business, but it's
oh no,
to build a business for 5 years and sell it to Google and make $1 billion or whatever, and then get out. And that's a
yeah,
very different mindset. So that also contributes to a lot of this, I think.
sure, and that's the reason they will never be Google, right? Because
Yeah.
they are looking for the short term, and the guys who look for the long term, they are like Nvidia, Google, all those guys who are really big players, like eating all the other ones who are not interested.
Yeah. No, that's a good topic. I want to circle back around,
Mm-hmm.
and I'm curious. So, we talked a little bit about training. We had talked
Hey,
earlier. You had mentioned that one of the challenges. So speaking of business challenges, one of the challenges that you face, and perhaps also some of your customers, is onboarding new people. So I think
yes.
that can kind of tie back into all of this, actually. So how do you, and I guess is the problem more training? Is it finding people, finding the right people? Like, can you tell me more about that?
Yeah, I think it's a combination of factors. For sure, first of all, it's to find the right people, the right fit, right? Like many times, I think like genius people, they are genius, but they are maybe not the best fit for your company, right? Because sometimes they don't play with people like fine together, right? And all those things that sometimes come with it. Some people, it's just it's good for that, right? Other thing, it's and that has to be evaluated, right, by the human resources like department, right?
Right. Yeah.
In theory, yeah. But then you have to do the onboarding proper, properly, and even the offboarding, I think it's important to get more onboarded people, right? The order to do that, to for people to have a good experience on that, it's keeps allows you to get more retention, which is part of the problem. And in the onboarding, it takes a lot of time, especially in our line of business. That people has to be properly trained, right? So they have to follow, the senior engineers and look how is it done, and you have to train it so they understand what the senior engineer is doing. And it's a lot of investment, I think, and that's something very difficult. I cannot say we have an answer for that. It's a tough question. How do you create and retain people with enough knowledge to do like a kind of not kind of advanced engineering, right? It's it's always an issue, but the main parts takes a lot of time, a lot of resources, and it requires a lot of order, right, to keep them in there, like a lot of constant feedback also from the guy, because everyone is different, right? Everyone needs something different to be working in the company, right? So yeah, you have to be like very very attentive to that. But yeah, it's kind of hard in that sense.
Yeah, your feedback about individualized stuff is interesting because everybody is different. Everybody has different motivators and
Yeah.
different things that they need help with. I remember somebody telling me a story once about this company that wanted to encourage their salespeople. So they decided that whoever won the sales competition would get the Steak of the Month Club or something.
Uh-huh.
And the lady who won was a vegan.
Oh. Yeah,
So like
that
she
was
was
not the
not very happy,
motivation.
right? Like, yeah. So like, yeah, that was actually demotivating. I think she ended up quitting after that. So it's
Okay.
like, like, and the company's intentions were good, right? They wanted to encourage them. They were giving them the
Yeah.
carrot, right? They're like, hey, here's this thing. But yeah, so it does need
Yeah.
that. But going back to your thing about the genius, I'm convinced that yes, there are some genius coders, and like, okay,
Yeah.
that's cool. As you said, sometimes they come with some baggage, right? It's easy
Yeah.
to be
Exactly.
toxic if you're the genius coder. But I'm convinced that everybody searches for A players. They all want the genius. But I think if you take the B players, the people who have some knowledge, but they're not like standout stars. If you take them and you give them good training and you get a group of them and you get them to
Yes.
actually work together, I think that outperforms any genius. Like
Yeah.
it's more about the system because you could take a genius and you put them in a bad system and the system's going to win.
Yes.
So
Yes.
having a good system and then just like the B players tend in general to work better together.
Yes.
And there's a lot of
Also, they
stuff too
work
that you can
harder.
train. Yeah.
They work harder. I think hard work always outweighs genius. Like
Yeah. Well,
maybe not always, 99%, right? But yeah.
geniuses do tend to be lazy. And I say that as
Yes.
somebody who like in my high school, I was like one of the smarter kids. And I don't say that to brag, but like it made me lazy because I realized that I could still get good grades without working hard.
Yeah.
And so the working hard part just like eventually came to me in college when I went from like big fish in a small pond to like guppy in the ocean. And I was like, oh crap, I really got to work hard now. And that was a shock.
Exactly.
But yeah, that probably says more about my
Exactly.
small town than me. But
Exactly. That's the thing. Like people and they get used to work hard, and in the end, everything they do it like because they are used to it. They do it working hard, right? And as you said, they play better in teams.
yeah.
Yeah, I think I also have that opinion on that.
But also though too, I have an issue with the idea of working hard. It's not that like you shouldn't work hard. Like I think it's necessary, but I think sometimes people put too much effort on working hard. And particularly as a software engineer, I want people who work smarter in the sense that
Yeah.
like, okay, you can work harder by doing the same thing over and over again and do it 100 times. Or you can work
Hmm.
smarter by I do it 2 or 3 times. I'm like, hey, I can automate this. And next thing you know, oh, I can do
Yeah.
it, right? And it comes out way quicker because instead of taking 100 hours, it took you like 50 hours. And now you have that tool that you can continue to use. So I think there is a little bit of room in programming for the, I call it like opportunistically lazy, like
Yeah.
just having that sense, like in LabVIEW, I think like there are several underrated skills in LabVIEW. I think one is refactoring, but the second one
Yeah.
is actually scripting and being good at it and knowing when it makes sense to automate things and when it doesn't.
Yeah.
And it's like the XKCD comic where it's like, how much time can I spend before it pays off? I don't know
Yeah,
if you've seen that one, but yeah, it's really good. And it's like having that sense of what's possible and knowing how good you are at it and how long it's going to take you to automate something and having that sense is actually really, really valuable.
yeah. No, that's actually it's the lazy engineering thing, right? To be a good engineer, you have to be a
Yeah.
little bit lazy too.
Yeah. But then that brings up another point, though. People talk about like 10x engineers, like they themselves are 10x more productive. But I think a really good engineer, 10x is not themselves, but the team. So if you're the person who can do that type of automation stuff, you sped up not just yourself, but you sped up the entire team. Whereas
Yeah,
a genius might be able to do that faster, but they're not going to speed up the entire team.
yeah. Also, it's not going to give away the knowledge because normally
They thrive on
since
being the genius. Yeah.
yeah, exactly. Yeah. So that's another thing. You need to play properly in teams, right? Yeah, that's a very important skill for every company, I think, if you
Yeah.
want to grow.
Well,
Yeah.
I feel like in software engineering in general, I see this a lot in the LabVIEW world, but like, and maybe you see this, but I feel like we call ourselves a team, and I've worked on
Mhm.
teams where 90% of your work is done by yourself. And then once a day you get together and you say, okay, this is what I worked on. And I'm like, okay, that's fine, but like, are you really a team if that's like the only interaction that you have?
Yeah, I think it depends on which, let's say, level you are, right? Like you should maybe divide it. Like, no, I don't know. The junior engineer should do the code and they show it away to other guys. So hey, maybe it can be corrected. The other engineers who have to do their work and they teach other ones, right? Spend more time showing what they are doing, maybe
Mhm.
teaching, mentoring, and the seniors even less time programming and then more showing stuff they are doing, right? Like they are prototyping or whatever.
Yeah, exactly. Yeah. I mean, I think like, right. Okay. Yeah. So you're a senior engineer. So if you're left alone to your own devices, you can produce code faster
Yeah.
than a junior engineer. So, okay, wait, we'll throw them over there by themselves. But what you're missing out is that by that junior and senior engineer working together, the junior engineer gets
Yeah.
faster too over time. And that's how you build up because I feel like there is this, we're bad at building up the next level of seniors. We're really bad at promoting people internally and building up their skills. And I think part of it
Yes.
is like the way we do work. And I think that like working in silos kind of kills a lot of that. And also, I think like people just, companies and managers don't think ahead well enough, I think. And they also like, we have this idea of like, oh, we need a senior person. And we don't stop and think, well, how can we bring up the people internally? We immediately think, oh, let's go hire somebody who's already an expert in this. And
Yeah.
that
Yeah.
also
I
kills it.
I think sometimes I would say that sometimes you need blood, right, to go into that. For example, let's say it's not a senior engineer yet, but as you said, you promote it to senior engineer, and there's a lot of responsibilities that come with that. But the thing that actually it comes to that, and you will ask of that person more. It will be better. Maybe will be good for them to advance on that. And for sure, there will be, as I said, a lot of blood in that. Like he will suffer, kind of, but he will learn, right? And he will go up to that level, right? In the end, I think. But
Yeah.
yeah, it's part of it, right? To go into new things, it's a lot of work, right?
Hmm. Yeah. So wrapping up, there is a question I was asking everybody. Can you tell me about an experiment that you tried that didn't go the way you thought it would and what you learned from it?
Like that it worked or that didn't work.
Uh, it can work or not work, just like that surprised you.
That surprised me. Well, I think experiments. Well, in my master, I think I did some experiments, but for example, in the master's degree, I think one of the things I was surprised it didn't work because I didn't understand that at that time how computers work a little bit deeper. We had to do this small filter, right? So we had this sensor. The sensor was a piezoelectric device. It had to be very fast, and because it was measuring cracks in a small piece of a composite. It's a composite material, and it's a lot of noise. So you have to filter it, right? So my first approach was to do it in software, right? To filter in software, and since I required more and more, filters, yeah, it became very very slow, and the computer was very fast. So I was very surprised of that. And then I had to build in hardware, and it was very fast. And I said, okay, yeah, then hardware is it's a cool thing if it's dedicated to that stuff. That yeah, that's what was one trial and error I did. Yeah, yeah, but you have to, in order to avoid that, you would have to understand properly, right, how to do it. And I
Yeah.
read about that, but still I didn't believe it until I saw it.
Yeah, well, that's also one of those things that hardware software interface, like if you think you can just get software engineers to work on LabVIEW projects who don't have
Yeah,
any hardware background, it's hard because there are certain things, like for example, right, you mentioned like filtering and stuff. Like there are some things like, you have to sample at a certain rate in order to capture whatever like frequency you want to
yeah,
capture, right? Like the whole Nyquist theorem thing. If you don't know that, I've been on projects where like, oh, we'll just fix that in software. And I'm like, you're
no,
not going to be able to fix it because the
yeah,
information's not
exactly.
there. Like, just doesn't
Yeah.
work that way.
Yeah,
Yeah.
exactly. And for me, even if I knew some of the theory, I didn't believe it completely, let's say, completely, right? Until I experimented on that, and yeah, I learned to believe the books, right?
Yeah. Well, that's also one of those things where like, good project management is to identify the risky things and do those first. So like if you don't know much about the hardware or how it works, like the first thing you should do is get the hardware and make sure that it can do what you want it to do. And
Yeah,
then you
yeah,
build
for
all the rest
sure.
of the logic around it, and that's fine. But like, yeah, doing the risky thing first so you have time to experiment with it. And you're
Yeah,
not
no,
like
for
under
sure,
pressure at the end of the project trying to
for
figure it
sure.
out. And then you figure out it doesn't work. And you're like, well, we wasted 6 months building the fancy UI, but the hardware stuff doesn't work. Well, like
Yeah,
that's waste. It
yeah.
would have been
That's
better to figure that out
that's.
earlier.
I think that happens a lot on the startups. This was another one that I work in a startup, like the beginning of my career. It was the second startup I worked, and that one was very interesting. I think because in the beginning we wanted to create a device that was able to observe if there is a disease right in your blood, but do it very fast. Only to four diseases was the goal, and to do it, it's because the blood reacts in a different way to different excitations, let's say, and that has to be built into a chip with some characteristics with gold and whatever. So the thing is, in the end, when the girl from was coming to Mexico because she was living in it's not Russia, it's some I not Ukraine, some place there, like around there. It is in an old U.S. an old Russian country, right? But she was coming to Mexico to do this experiment. She was the biotechnology girl, and we were doing this, and she didn't bring all the components. And we said, "Oh man, we have to adapt now." And we recurred to some guy in the university who had some components of that, and we said, okay, maybe we can adapt that. And he had, I think in Spanish is phagocytes, something like phagocytos, something like that. It's a bacteria that generates crystals around it. So
Okay.
it's so we wanted to use that so we can push the crystals and observe the reaction when the blood comes into contact to that, with the electrical reaction. So maybe we could filter that out and obtain the right result. But in the end, what was really interesting, it was what we were getting the result from the crystals. Not actually the experiment with the blood thing. What's a disaster, but we obtained that, and in the end they try to pivot onto that, on okay, what can we do with that, because that bacteria could be easily modified. Well, the biotechnology guys said it was easily modified, so you can do other stuff, right? And we said, okay, that's really interesting, and we went on to that, right? It was like a pivot of the startup somehow, but it was really interesting because it was an experiment. It totally failed and then kind of won somehow. In the end, the startup, died, but it was very interesting. Very interesting experiment, failure, win, and then die again.
Yeah, yeah. I mean, I guess that hits the point of experimenting, right? You learn things, even if it's not what you expected to learn. So
Yeah,
they learned
you
that there was some
pivot.
other interesting thing. And yeah, and I think I mean, that is startup culture, but that's also like, I mean, in engineering, right? Writing software, like I try something, it doesn't work. Okay, well, is there
Yeah,
another way to accomplish my goal or do something? Yeah, yeah, it happens.
yeah, especially if you bring teams with very different backgrounds together. I mean, for the biotechnology guys, it was very like interesting to see they can measure stuff from there. For them, even multimeters and stuff okay, it's a very interesting machine, okay, but they don't know how it works, and they start asking, oh, can you measure this? And can you measure that? We can do all this if you can measure that stuff, and you bring the team together in that sense, and yeah, many things can be done right.
Yeah. Cool. It's been a great conversation. Could probably go on longer, but I think we should probably wrap it up. Is there anything else that you want to
Sure.
say before we call it quits?
Oh, I would say just keep experimenting. I think that's cool. Keep learning, keep experimenting.
I think that's a great way to leave it. Thank you. That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at the LV Experiment.